All right, so we already went over a similar problem with this with an acid a few questions ago, but now there's one with a base. It says a weak base B has a concentration of 0.155 molar. If the pH of the solution is 11.24, what is the Kb of the weak base? So the first thing I'm going to do is write the Kb expression. All right, so the Kb expression is the concentration of BH plus concentration of OH minus over the concentration of B. Notice that water is not here again because water is not aqueous. So we need to be able to find a few of these things. Well, we have concentration of B, which we can plug into our ice table. We know these are initially 0. But the problem is if these become X's, we don't have Kb, right? We're not given Kb here. So we need to be able to find specifically the concentration of OH minus. Well, how are we going to do that? Well, we have the pH. And if you recall, the pOH equals 14 minus the pH, which is equal to the 14 minus the 11.24, which is equal to 2.76. So this is the pOH. Now we can find the concentration of OH minus, which equals 10 to the negative pOH, which equals 10 to the negative 2.76, which is equal to 1.74 times 10 to the minus 3 molar. So if you haven't already watched the one of these where we did it with an acid, it's a good idea to do that because I'm going over this relatively quickly because it's basically the same, except instead of using the pH, we're going to use the pOH. All right, now we can fill out our ice table. So the initial concentration of this one is 0.155 molar. The initial concentration of this is 0, and the initial concentration of this is 0. But we know that at equilibrium, we gained 1.74 times 10 to the minus 3 molar concentration of concentration of OH minus. How do we know that? Because we know the pH of the solution, so we know this must have been the concentration of OH minus. Well, if we gained this much OH minus, we must have gained this much BH plus. Why? Because for every B that reacts with water, we get one BH plus and one OH minus. So we must have also gained 1.74 times 10 to the minus 3 molar of this. Now here we could theoretically subtract 1.74 times 10 to the minus 3, but that's only about 1% of this one, so we don't need to do that, okay? So whether you do that or not, it's kind of arguable. All right, but I'm just going to put this as 0.155 molar and assume that this is insignificant. Over here, we get 1.74 times 10 to the minus 3, and we get 1.74 times 10 to the minus 3. Remember, our goal is to find Kb. Well, now we know all the things in the equation, so we can simply just plug in. So the Kb is equal to 1.74 times 10 to the minus 3 times 1.74 times 10 to the minus 3 divided by 0.155. And when you do all that math, what you end up with is 1.95 times 10 to the minus 5 as the Kb of this weak acid B, this weak base B. So this is how we would find the Kb of the weak base.